In this session, can everyone hear me okay?
Yeah.
Okay. So I'm going to talk about limiting reactant. And theoretical yield. I think why I skipped this, because technically there's another component called percent yield. And I don't think that's on the worksheet, but maybe we might as well talk about that as well. And so what I want to say is you use the limiting reactant to, oh, we got 12 now. Why don't you guys, can you guys text or email your pals and say, get back in here? Anyways, use the limiting reactant to calculate everything. Okay. So can you guys see this okay? Is everyone here? Everyone's quiet.
Yeah, it's fine.
Okay. So I'm going to use a metaphor. I'm making bicycles, okay? And here's my frames. I'm in a bicycle factory. I got this many frames. And I got and I have that many wheels. And I have that many whoops. That was too many. And I have that many handlebars. Okay, how many bicycles can I make?
2.
Yeah. So if I'm making bicycles, these are the worst bicycles you've ever seen, but here we go. There's 1.
What does the top part say? It says what?
I know. That's why I said
Was there a question?
And I said you decided to make cupcakes.
Can you push the paper down just so I could read what does it say? Limiting theoretical.
Yeah, so we're gonna cover limiting reactant, theoretical yield, and I'll talk a little bit about percent yield, I guess. I don't think percent yield's on the worksheet.
Okay.
I know about the whole limiting reactant thing that he's going
So
on.
I haven't defined any of those terms yet. I'm talking about, and a really important concept to put a star by this is to use the limiting reactant to calculate everything. But first I'm doing a metaphor. So we have all these parts and I'm making bicycles. And so somebody said, hey, with those parts, you can make 2 bicycles. And I'm gonna have some stuff left over, right? How many frames will I have left over?
1.
1 frame, and I'm gonna have, well, gosh, I'm gonna have 4 wheels left over, yeah? That I can't use to make a complete bicycle. All right, so in this example, the handlebar is what we call the limiting reactant. And the wheel and the frame are what we call excess reactants. We had more frames and wheels than we could use. Okay. So let's continue. So, oh, where's my camera acting weird? Come on, camera. Okay. So the limiting reactant gets completely consumed, right? So how many handlebars were left when we were building bicycles?
0.
There were 0. And the limiting reactant determines the maximum amount of product. All right. So, and the way to do this is, so kind of the steps for this is I'm going to put step 0 again, which is have a balanced equation. And then the first step is to use each reactant to determine the amount of the same product that will form. And this is actually, that's the hardest work. This is actually 2 equations. Or more, I suppose, if you had more than 2 reactants. But once you've done that, the reactant that made the least is the limiting reactant. So once you've done this hard work, oh, I
Sorry,
see.
Professor, this might be
Hold
a
on
little
just a
bit,
sec,
like,
people.
off
I gotta take the, I'm gonna put the video on my, oh.
Professor, I just had a question. It might be a little bit off topic, but is there a discussion for today?
No, I'm not having a discussion today.
Okay, like no like discussion post or anything like that.
Uh-oh, what happened here? Okay, good. Sorry, I just had to make sure because you guys wanted the recording, so I'm stacking my recordings on the desktop, and I'll figure out how to put them on Canvas in a second. So let's go back. Okay, so yeah, I'm not having a discussion today. I thought about having a quiz for the discussion, but I'm just going to leave it. And we have most of the class, although we are missing, well, 16 out of, I don't know how many, 28 people. The people are consistently not coming. They're going to have a hard time.
Yeah, Ramsey is.
And so my taking role is not really going to help them be here. So we'll see. Okay. Well, actually, I guess since I'm recording it, I think maybe in the future we should do a discussion. But I'm not. I told other people earlier that have already left that I wasn't, so I'm not.
Okay.
Anyway, so let's continue. So steps: balance the equation. Use each reactant to determine the amount of the same product that will form. Once you've done the first step, then the other steps are just an analysis of the calculations. And so from looking at the calculations here, whatever one made the least is the limiting reactant. And that amount is actually what we call the theoretical yield. And so we should also mention the theoretical yield. The theoretical yield is the maximum amount of product that you can make. Okay, I'll put that over there. Okay, so theoretical yield is the maximum amount of product that you can make. Let me, just for a second, let's go back to the bicycle factory. What was the maximum amount of bicycles that we could make?
A whole 2?
Yeah, so 2 bicycles, that's my theoretical yield. I suppose if, you know, the bike mechanic really cranks on one of the handlebars and breaks it, then I don't get to actually make 2 bicycles. I mean, I only get to make 2 bicycles if I'm successful in putting them together. Does that make sense? But at best I could make 2. I can't make 3. I don't have any. I ran out of handlebars. My limiting reactant is gone. I can't make any more than 2. Okay. So let's do that with a chemical reaction. So let's go back. I'm going to go back to the Haber process. Nitrogen plus 3 hydrogen goes to 2 ammonia. So if 2.5 moles of nitrogen react with, let's say, 5.7 moles of hydrogen, comma, how much NH3 can be made? Question mark. And what is the limiting reactant? Question mark. All right. So this example is a little bit more simple, but we're just gonna go from moles to moles. So step 0, balanced equation. That's above. Step 1, 2 equations to find product. So here we go. I have 2.5 moles of nitrogen, and how many moles, according to 2.5 moles of nitrogen, how much ammonia could be made? What's the mole ratio? What's the balanced equation tell me about the mole ratio between nitrogen and ammonia? You guys are so quiet. We were doing this earlier. Nobody? Okay.
2 to 6? No.
You look at the coefficients here.
Oh, is it 1 to 3 is 2?
Now just look at nitrogen and ammonia. We're gonna find product. So this is a product. These are reactants, right? And I'm gonna use my handlebars and frames to figure out how many bicycles, right? So what's my nitrogen ratio to ammonia? Let's call nitrogen the handlebars. How many handlebars?
1, right?
1 handlebar to how many? I guess it's not called handlebars, but how many nitrogens will make how many ammonias?
1.
Okay. Yeah, so someone's texting 1 to 2. Where's the 2 have to go? Where's the 2 have to go?
Up top.
Yeah.
Up
2
on
moles
top.
of ammonia, 1 mole of nitrogen. Okay, well, that's pretty easy. 2 times 2.5 is 5. Well, actually, let's make it 2 sig figs. 5.0 moles of NH3. Okay, so that's the first equation. I'm going to call that A. Let's do the second equation, B. I also have 5.7 moles of hydrogen. 5.7 moles of hydrogen. What's the ratio of hydrogen to ammonia? Nobody?
Is it 3?
Yeah, there's a 3 for the hydrogen. 2.
2?
3 to 2. Okay, so where does the 3 go?
On the bottom?
Yes. 3 moles of hydrogen on the bottom, cancel. And 2 moles. Maybe I should we should cancel out units here too, right? Moles of hydrogen with moles of hydrogen. Just like above, we canceled moles of nitrogen with moles of nitrogen. Okay, So then I'm going to have, this one's kind of more complicated. I need my calculator. So 5.7 times 2 divided by 3. And I get 3.8 moles of ammonia. Okay. So this one's kind of cool, actually. If you look at this, I had more hydrogen, but it made less ammonia. Why is that? Why is that? I had more hydrogen than I had nitrogen, but it made less ammonia.
Because
Buddy?
you still have the limiting.
Yeah, so he's saying, so this is less. So now we're doing step 2, is basically compare, right? So this is less. So go back to hydrogen. If that's less, then hydrogen is limiting, right? Another thing we could say, so we can't make, let me cross this one out. We can't make 5 moles of ammonia. Why not? I mean, think about my bicycle factory. I can't make 3 bicycles. I'd like to make 3 bicycles. I can't, right? I run out of handlebars. So I can't make 5 moles of ammonia. I can only make 3.8. So hydrogen's limiting. The other thing we can say is 3.8 moles of ammonia is the theoretical yield. That's the maximum that we could make. Yeah? Okay, and so someone was saying, yeah, you couldn't, because you're dividing by 3 here, you can't make, you make a lot less, right? It's because of this, it's because of those mole ratios. They're super, super important. It looks like we have 16 people now. So we got most everyone back in, which is good. Okay, so this example is the easy example because I just did moles to moles. I could make this more complicated by giving you grams. Are you guys ready to see one of those?
Yeah.
Okay. The other thing is, let me be clear too. We can have different products. So let me use a completely different situation. How about calcium hydroxide plus 2 HCl goes to 2 water plus CaCl2, okay? And if, let's make them the same amount. If 10.0 grams of calcium hydroxide react with 10.0 grams of HCl, comma, how many, to make it easy, let's go to water. I mean, I could choose either product. How many grams of water can I make? Question mark. Okay. So you guys ready? So it's the same process, right? So step 0, balanced equation, done, right? Step 1, 2 equations. I'm going to take the 10 grams of calcium hydroxide. What's the molar mass of that? So I'm going to cheat. Oh, come on. Why isn't it? No, it's not working. What's the molar mass of calcium hydroxide?
40.1.
40.1 is just the mass of calcium. Do you guys want to see all the work for calculating the molar mass of that? Okay, fine. Let's do that. Okay, let's find calcium hydroxide. So calcium hydroxide has 1 mole of calcium, which is, I think it's 40.08, and 2 moles of hydrogen. Is that right? Because the 2 distributes, yeah? And 2 moles of oxygen. So 2 moles of hydrogen is 2.02, 2 moles of oxygen is 32, right? 2 times 16, 2 times 1.01. Okay, so if I add all that up, I get 0, 1, 74. Is that okay? Let's also find HCl. HCl is 1 mole of hydrogen and 1 mole of chlorine, which is 1.01 plus 35.45, which is 36.46. Yeah? Is everyone on board with what I just did?
Yeah.
Okay. So I haven't done the 2 equations yet. I've just calculated the molar mass. Now, equation 1 or A, let's make the first equation. Let's take the calcium hydroxide. 10.0 grams of calcium hydroxide times 1 mole of calcium hydroxide to 74.10 grams. Let's cancel out the grams. Okay, what's the mole ratio between calcium hydroxide and water? You guys see that? Anybody? Ramon has unmiked? No?
Yeah.
What's the mole ratio of calcium hydroxide to water?
1 to 2.
1 to 2. Where's the 2 go?
On the bottom?
It's 2 moles of water. I want actually on the top, 2 moles of water, 1 mole calcium hydroxide. Okay. And then we could just find the moles. Let's just find the moles. Okay. And I got to do it with the second equation, B, 10.0 grams of HCl. These are actually going to be pretty close to each other. Times 1 mole of HCl, 36.46 grams. And then what's the mole ratio of HCl to water? Oh, yeah, there it is. HCl to water, what's the mole ratio?
2 to 2.
2 to 2. Okay, I'm recording, good. All right, so let's put that, doesn't matter, 2 moles of water, 2 moles of HCl. Okay, and whatever that is. Okay, so then it's time to do the calculator. So the calculator, the calculator says, for the first one, 10 divided by 74.1 times 2. So this one here is 0. Let's say 3 sig figs. I'm going to put 4. 0.2699 moles of water. And then this one here, let's see what this one does. 10 divided by 36.46, well, times 2 divided by 2 is just times 1. And that is 0.2742 moles of water. Okay, so which one makes less? Yeah, so Shams is saying the top. This one here is the theoretical yield. Forget about that. That bottom one was just a waste of a calculation. Well, we needed to see that it was more. And then this here is the limiting reactant. Is that okay? All
Can
right.
you explain I got lost. You know how we found out the molar mass of 1 mole of CaOH on right here at A, the first equation? Right
Here?
there, yeah, I got lost there. Yeah. Can you go
So
over?
this is the molar mass.
Mm-hmm. Yeah, molar mass.
And that was calculated up here.
Mm-hmm. And then what did we do after that? Oh, we found the ratio of the equation, right?
Yeah, so let me, here. So what did we do? Hold on a second. He's got a good question. So for each reactant, we went from grams of reactant 1 to moles of reactant 1 to moles of product. And here I'm going to say product 1 because we actually have 2 different products, right?
Yeah.
So this was A, right? We went from grams of calcium hydroxide to moles of calcium hydroxide using the molar mass. And then once we had moles of calcium hydroxide, we canceled the moles of calcium hydroxide and got moles of water. Yeah?
Yeah, good.
Okay. And then, so we also did that for the second one, right? We went grams of reactant 2 to moles of reactant 2 to moles of the same product, product 1. These have to be the same over here, yeah? If they're not the same product, then I can't compare it. So let just go back to the equation for a sec. If I had used the calcium hydroxide to calculate calcium chloride and used the HCl to calculate water, then I have 2 different things. I can't compare them. But what I did is I used both of them to calculate water. Then I could compare and said, aha, this one makes less water than that one. Yeah? Okay. So technically we're not done. So then the maximum amount of water, I want to go to grams, right? So I'm going to take this value here, 0.2699 moles of water, and I'm going to multiply by, what's the molar mass of water? Anyone remember? 18.02 grams. We did that from before, right? I'm cheating. So 0.2699 times 18.02, and I get, well, this reaction, I have 10 more minutes, but that's probably good. So from this reaction, I can get, and now I want to look at sig figs. This was 3 sig figs here. So actually, I can make 4.86 grams of water. That's the maximum. Any questions about that? So we had that one question. Did I answer that other question about how did I do the molar mass and everything? I hope I answered that. You're going to want to practice this. And there, again, so let's say some stuff that, you know, the PLTL Center has, you can Zoom PLTL and you can get help. You guys can email each other or Zoom each other. You can email me. So we can get help with this. Yeah.
Also, I wanted to ask, what time, like, what's the best time to like contact you, or like, do you have office hours? During this
We
whole
can
situation?
set up one if people want that. It was Wednesday. after my AM class. So it was Wednesday from 12:20 to 1:20. Whoops, didn't write that right. Excuse me. My penmanship is disgraceful. 12:20 to 1:20 is typically a good time. So if someone emails me and they want to meet, we could set up a Zoom for that time if you need extra help. Yeah?
I was wondering like if we can like set up a Zoom, like I don't know, like for anyone that wants to join, you know, see if they have any questions as well, or it depends like if it's
Yeah,
going.
well, if people email me and want to Zoom with me, that would be the time to do it. Whoever wants to, then we could do that. We could do that Zoom time, I guess.
Oh, okay. So
Is that
just
all right?
yeah. Okay.
So that's kind of, and that's a day before the lab is due. So, why don't you try, I would go PLTL. You guys know you can get massive extra credit for that, right? You know that. I
Yeah.
believe every teacher at San Jose City, at least in the science and math department, allow you can get plus 2.5% onto your GPA. That's crazy, wouldn't you say?
Yeah, that's pretty good.
So why don't you try to figure it out? And if you
Yeah.
get stuck, then each other. And then if you're still stuck, then hey, Mr. Canton, let's Zoom, please help me. Okay?
Okay. Yeah.
All right.
There's a comment there's a comment in the
Oh,
chat.
on the chat, let's see.
Yeah.
Would I be willing to go over what's on our study guide? Is there a link for the PLTL? So I don't, for your study guide, do you guys have a test coming up? I don't even know. You have a test coming up?
Yeah,
We have
Monday.
our midterm.
Your midterms on Monday?
Yeah.
I would expect Leclerc to do a review maybe. Is
I
Leclerc going
think
to
it's
review?
actually in 2 weeks. It's on the 6th, right?
Is it on the 6th?
I
No,
know it.
she said Monday.
Yeah, Monday. This Monday coming up thing.
Well, okay, so this Monday is the 30th. So I would be clear with her. So if she did she do a review?
No, she just gave us a study guide.
Oh. Okay. Well, okay, so there's two questions. So one's the study guide, and the second question is linked to PLTL. Maybe PLTL is the way to go here, but let's do that first. So I'm going to get out of the video for a second. Actually, I don't know if I'll be able to get back. I have to figure out how to do that, but I'm going to go to the screen, okay? If we get stuck, I can also go to the whiteboard, but okay, so let's go. I'm going to go to desktop to show you PLTL. It's pretty darn easy. Where did everyone go? It didn't highlight. Where is it? Can you? Oh, you're still in camera. What happened? Desktop share. Can you guys see the desktop?
Yeah, we can see it.
Yep.
Okay, usually it's outlined with green. Okay, so then you can see, okay, so check it out. Can you guys see this page?
Yep.
Okay, so here's what I'm going to do. I'm going to go to whatever my search window is, and I'm going to type SJCC PLTL and peer-led team learning, San Jose City College. Click on that. Scroll down, chemistry, and there you go. So there's Ha and Min, and these are their workshop times. So it looks like Min has a Friday workshop, Maybe you can get Min to go over your test review. Or you could spend a whole hour and a half. Does that sound reasonable? Hello?
Yeah,
Yeah,
that sounds
yeah,
good.
that's good.
Yeah.
I mean, I have
we
a
have to
limited
register
amount
for
of
those?
time here tonight.
And do we
Let's,
just show up?
okay, so let me, hold on. So while you guys see this, right?
Yeah.
Yeah.
And does everyone know how to get there? Okay, if you don't know how to get there, let me know. Send me an email. Okay.
Do we have to register
So,
for these or no?
question?
I don't think so.
Like, how do we get the credit that we showed up for them? Do they just
So
tell you?
if you're zooming in, they're gonna have your name down there. There's probably some sign in when you zoom in. And so to get the maximum credit, you have to zoom at least once per week. If you do extra zooms per week, or extra PLTL per week, I don't think it gets counted, but you have to do 10 weeks of this to get the maximum, and anything less is a little bit less. Does that make sense? No?
Yeah, makes sense.
Okay. All right.
All right, I think that's it. Thank you, Professor. I'm gonna log out.
You're gonna log out. Okay.
Yeah.
So other people had questions. So I was gonna do something else here. How many people are left here? Where's my?
Like
Oh, I still
13.
have 13. Okay. So what I was gonna say, let's go back to the website and let me look at. Is there a study guide? Where's your study guide? Anybody? Where's the study guide thing?
I think she sent it in an email.
Yeah, it was in an email.
Oh, well, I don't even have it, you guys. I haven't. She hasn't emailed me since she uploaded this worksheet. So I don't know. Yeah, I'm not sure. Okay, well, this meeting's going to end in a minute. Do you guys want to come back in, or do you have questions? Does anybody need extra help? Anybody?
Are you like accessing your email throughout the day? Like if we like send you a message on Canvas and stuff?
Yeah, so I don't respond instantaneously, but if you send me an email, I will respond.
Okay.
This meeting's going to get, if you guys have questions, this meeting's going to end. Let me stop it and start it again. Okay, hold on.